questions.
Yeah, I was just going to say this is our last meeting for the season. We will be having some field days. Tenzin is hosting a field day for us this year, actually. So be on the lookout on the listserv for some more details for that. And with that, Natalie, I'll pass it off to you. Thanks so much for being here today.
All right, sounds good. Um, Hi everybody, I'm Natalie. I'm the Minnesota Extension Vegetable Crops educator. Um, and so today we're going to be talking about soil tests, how they apply in no-till systems. And I always like to start by saying that I'm not a soil scientist. Um, but yeah, I've been in this role supporting vegetable farmers for about 7 years. And I think from the very beginning, it was really clear to me that soil health and nutrient management were like some of the trickiest questions, the most complicated questions, that both involve a lot of math, but also require a lot of just like observing the system and understanding that it's biologically complex and there's kind of an art and a science to it, I guess. And so, yeah, I've been trying to understand these soils for the last 7 years or so. We did the 100 Farms project in Minnesota in 2023, where we really got a good snapshot of soils at 100 vegetable farms in the fields and in high tunnels, and some understanding of how practices influence soil health and nutrient management. Um, and so in my like perfect world, we would spend a whole day together. And we would spend the first, like if I were coming to your farm, we would spend the first like hour and a half in the field doing a soil health assessment, like looking at soil structure and looking at soil biology, and then sort of connecting that to soil test results. But we're obviously not going to do that this morning. Um, and so it actually would be helpful for me to hear, like, if it's more helpful for you all to do more of a deep dive on like what kind of testing is useful for reduced tillage systems and vegetable systems, and like how do we like understand some of the nuance of soil health results, or soil testing results, or is it more helpful to just get into the nitty gritty of like let's do a calculation of like figuring um, how much fertility to apply to the soil?
Speaking for myself, I am really interested in soil testing and I do a lot of my own analysis and stuff like that. And I use a sort of an Albrecht based system. Um, and I don't really have no-till
Okay.
situation going on. I'm doing a lot of things to maximize the effectiveness of the tillage that I do, and a lot of things to atone for the sin of tillage is how I think of it. But I'm not in a situation where we're not inverting soil layers to be able to incorporate amendments. I
Yeah.
am, however, really curious. I have a few like thorny questions just within that sort of Albrecht style, which I don't know if that's what you use or are familiar with or what, but so I'm really just here to kind of like learn more about other approaches too. I've been starting to help some other people with stuff, and a lot of times that Albrecht approach doesn't make sense the way I understand it.
Mhm.
And so I'm just kind of here to learn more about other approaches, and also if there's time and whatever, I'd like to get your insight on a few weirder questions.
That's good. Okay, I think we're gonna do what my initial hunch was and talk more about like different approaches to soil testing. And then if anyone wants to do like that follow-up of like, let's look at a soil test together and like come up with some calculations, I'm happy to do that a different time. Um, okay, let's do that. So I'm gonna be mostly talking about like pretty traditional soil tests and how they sort of work in the context of diversified vegetable farms, um, with maybe some nuance about no-till. But I'm also going to talk about these other sort of add-on tests and when it's worth it and when it's not. Um, Again, with the caveat that I think we're all still learning a lot because the soils on diversified vegetable systems are really complicated and really different from field crops. Um, so I sort of said this at the beginning, like I never, almost never, if I can help it, just look at a soil test and then like start to make recommendations. The goal is that I could be there in person or that we at least start with some questions about like how did last year go? Like how healthy were your plants? What were some of the challenges? When you go out into your field and you observe the soil, like what can you observe with your own senses? What are you seeing in terms of soil texture? Are you seeing good aggregation? Are you seeing compaction or crusting? What sort of signs of life are you seeing? We like to see three different types of life. So not three earthworms, but like earthworms, maybe some hyphae from mycorrhizal fungi, different arthropods. Um, so basically looking at like soil structure, soil biology. Um, and we actually have like a process that I'm happy to share with y'all. I can email it to Emily at the end, and like a soil health scorecard that you can do on your own. And we'll hopefully have a video of that soon. But I find that to be a really helpful basis for then starting to look more at fertility. With the basic idea that like soil health is this combination of physical, chemical, biological aspects of soil, and a soil test is giving you this like tiny snapshot of the soil chemical health. And so we need to think of that as a piece of this bigger picture, um, and a picture that really interacts. So, like, our soil physical health and biological health absolutely affect soil chemistry. When we have higher soil organic matter, when we have reduced tillage, we generally see more microbial diversity. Soil organic carbon feeds microbes. Those microbes, in turn, are making our plant nutrients available. Um, when we see um, yeah, like mycorrhizal fungi in the soil, they can, again, make plant nutrients more available. They can decrease leaching. And so these systems are all kind of working together. And what makes vegetable systems in general, I think, especially reduced tillage, but overall diversified vegetable systems really unique and a little bit different from field crops, is that we often have very high organic matter. We're working in compost heavy systems. Um, that means we sometimes have lower bulk density of the soil. And so our assumptions about the concentration of nutrients in a given slice of soil are maybe not accurate. I'm going to talk more about that in a bit, but that especially impacts potassium. Um, and I think we have some assumptions that when we're using a lot of compost, it's hard to get enough nitrogen into the system. So we sort of have this general assumption that we're going to see high phosphorus levels, potentially high potassium levels, and low nitrogen levels in the soil. Um, and that is maybe not always what we see, but that's sort of the assumption in a system that heavily relies on compost. Um, so I'm going to share just a little bit. So we did this 100 Farms project in 2023 where we went to 100 Minnesota vegetable farms. I'm going to share a little bit about the practices on those farms so you can sort of, I guess, in your mind, be like, how similar am I to these farmers? How different might my farm be? Um, in general, people were using composted manure as their primary input in terms of frequency of use. This is pretty limited data because we weren't trying to like quantify very meaningfully how much people were applying, but generally composted manure was kind of the go-to. Vegetable compost was pretty common on a lot of farms. And then these organic supplements would be things like blood meal or bone meal, different micronutrient blends. Not a lot of farmers are using fresh manure, though certainly some are, and even fewer are using synthetic fertilizers. So a complete fertilizer would be like a 10-10-10 sort of thing, versus nitrogen, which might be more like urea or ammonium sulfate, something like that. And what we saw in this was that there's a lot of confusion about the word compost, that we use it to describe some different things that have different properties, like compost manure versus animal or versus plant-based compost versus like mushroom composts. And even though most farmers are taking soil tests, we see that, like, I think the average farmer will take a soil test, get it back, and then be kind of like, I don't know what to do with all these numbers. And that's our fault. Like, we don't have a lot of support for farmers to understand their soil test results, especially in a system where we're using nutrients that are less predictable. And so what we kind of saw was that even though people are taking soil tests and generally using them to influence decisions, people are often still using as much compost as they have available or like a set amount every year. And that in turn impacts fertility. And so when we look at like the standard soil test, it's telling us a few basic things. And it's a pretty limited picture. A standard soil test is going to tell us soil texture, organic matter, the pH, and your nutrient needs, generally for phosphorus and potassium. Those things range from less controllable, you can't do a lot about your soil texture, you just have to work with it, to things that are pretty easy to adjust, like your nutrient needs. When you take a soil sample, you're trying to get a good comprehensive picture of your field, just because there's a lot of diversity from individual spot to individual spot. And so I typically recommend 15 to 20 cores per plot area. And there's really no right or wrong answer about how many distinct plots is right for a farm. I usually say, like, take the amount of data that you can use. If you are overwhelmed by nutrient management and you're kind of just going to do the same thing to all of your fields, then just do one sample that represents all of those fields. If you're really going to like take the time to manage each field differently, then it's probably worth it to measure those fields differently. And a high tunnel is a really unique space. And so I recommend every high tunnel every year as a separate test. So we're going to look at some soil test results from kind of standard soil labs and just kind of maybe bring a little bit of nuance to some of the results that we tend to see. So this is a University of Minnesota soil tests. We've got soil texture, organic matter, pH, phosphorus, and potassium. This one also has nitrate. The Wisconsin lab has the same stuff. It looks a little bit different. Instead of these like colorful bars, you get a bunch of stacked P's and a bunch of stacked K's and a bunch of stacked X's. That's what I just used to look like too. So yeah, this test kind of has the same stuff. It's got your soil pH, organic matter, phosphorus, potassium, and then you can pay for these extra tests, usually for micronutrients. Your private labs are gonna kind of they all look a little different, but they've got the same information. Here's from AgVise. Midwest labs, they just have like a VH is very high, H is high, L is low. And so what I think is worth saying about the different labs that you use is that different labs sometimes use different tests. And so it's really important to use a lab that is calibrated to the soil in your area. So I would never send a sample from Wisconsin to New Hampshire because they're going to use a Malich 3 test probably, or modified Morgan for phosphorus. Versus here in the Midwest, we tend to use a Bray or an Olson. And that is just like, what kind of chemistry is the most likely to get an accurate response based on the chemistry of your soil. So I would use that DATCAP list of labs that they recommend because those soil labs are doing tests that are specifically like adapted to your soils. The
Can
other
I jump
difference is,
in briefly,
yeah,
Natalie?
yep.
So, Yeah, the DATCAP list lists labs that are certified by DATCAP and can be used if you're making a nutrient management plan that meets Wisconsin requirements. So that's an important thing to know about as well, so that the test you're using to create a nutrient management plan is actually going to meet what DATCAP requires. And the other thing is that the UW lab tends to get pretty backed up with research samples. So in terms, I completely agree with what Natalie said about like use a lab that is nearby and consistently go to the same lab if you can. So just knowing that that lab does get a bit backed up, if there's a lab that's close to you that you want to use, sometimes people in those labs can be really helpful in answering questions and helping you interpret results. So it's an opportunity to develop a bit of a relationship there as well.
Mhm. Yeah. The other difference that's worth pointing out is that your numbers for like what is the actual amount in your soil should be fairly similar from lab to lab, but the interpretation is going to be different. So the University of Minnesota might say that your phosphorus is very high. A private lab that is connected to fertilizer sales might say that your phosphorus is medium high. Um, and that comes down to different philosophies about nutrient management. The university labs tend to have a philosophy that's more like balancing water quality and environmental impacts and also farm finances, where basically the goal is to apply the amount that you're going to use every year. So you're applying and then you're drawing it back down. Whereas some private labs may have a philosophy that's more about building and maintaining high levels of fertility. They might argue that there's reduced risk there, that you're going to run into a deficiency. I think on the other hand, the risk of doing that build and maintain is you're spending a lot of money to bring your levels up and you're risking those nutrients leaching out into the environment. So that is worth knowing that the interpretation might be different, even if the numbers are similar. I'm not going to say a lot about soil texture right now. We're going to kind of go through each of these things that we see on a standard soil test. I'm not going to say much about soil texture other than sometimes, like, the thing that I like the least about our soil tests is they just say soil texture is fine, medium, or coarse. I would love it if they gave you more of an accurate soil texture. Um, but again, this is not something we can really change. It's just like knowing the texture of your soil affects the ways that you manage your soil with irrigation, with the way you're doing nutrient management. So if you're on a really sandy soil, you're going to have to be more careful about doing split applications so that you're not risking nutrients leaching out of the system. That's less of a risk in a clay soil because a clay soil can bind nutrients really well. So soil organic matter. I think this is the most complicated question in vegetable systems and reduced tillage systems. Organic matter is obviously really, really important to soil health and function. It is a reservoir of carbon and nitrogen. It helps to aerate our soil. It helps with water infiltration, helps with water holding capacity, as well as drainage. Organic matter is really important and really valuable. But I think there's sometimes this feeling that more organic matter is always better. And so, yeah, we add organic matter to the soil all the time, either intentionally through compost or through residues, manure. We are adding organic matter to the soil when we're using organic fertilizers like blood meal, bone meal, kelp, soybean meal. And I get this question a lot, is like, how much organic matter is enough organic matter or the right amount of organic matter? And the answer is really unsatisfying. It's that it totally depends, that it depends completely on the texture of your soil, on where you are. The further north you are, the colder your winters are. Generally, like your soils can store more organic matter because there's less breakdown. So like a prairie soil in Minnesota is going to hold way more organic matter than a tropical soil. A clay soil is going to hold more organic matter than a sandy soil. So if you had super sandy soil and you had 3% organic matter, that would be a lot of organic matter. That would be amazing. 3% organic matter in a clay soil is not that high. It's kind of medium to low. But I think looking at a spectrum is sort of helpful for context. And I'm sorry, I don't have good Wisconsin numbers, but hopefully this is still helpful. So a native prairie soil has somewhere between 4 to 7% organic matter. The average Minnesota farm soil, so if we look at the University of Minnesota Soil Testing Lab, like 130,000 soil samples that were taken from 1998 to 2016 or 2018, the average Minnesota farm has about 3.95% organic matter. In our 100 farm study, vegetable farms had 4.7, so quite a bit more than the average farm soil in Minnesota. And high tunnels had 6.3% organic matter, so quite a bit higher even than fields. When we look at community gardens in Ramsey County, that's where St. Paul is, the average community garden is at 9.6%. Raised beds are at like 17.5. And so the average farm, the average vegetable farm still has like fairly high, higher than most farms, but like not 6, 7, 8% organic matter. I think when we do start to see farms that use a lot of no-till practices and especially use deep compost mulch as a way of achieving those no-till goals, we start to see organic matter creep up towards like 6, 7, 8, even like 12, 15% at times. And I find it helpful to consider that like at 20%, we no longer really consider soil anymore. It becomes a muck soil or a peat soil. And so it's almost like you've created a peat bog in your field. You haven't, because a peat bog is a really, really specific type of ecosystem, but you're more working with something that's like potting soil-esque than regular soil, and that really changes the dynamics. So can too much organic matter be a problem? Not necessarily, but often we see that when people are using a lot of compost, you can end up with high salts. That's especially true in a high tunnel where we don't have the rainwater to leach the salts out. And sometimes what we see in the field is that people will apply like a thick, fresh layer of compost. Seedlings will die or not thrive. But then if we test the soil in the fall, those salts have already leached out by then. So in the field, it's like you get that flush of salts early in the season, right when your seedlings are most vulnerable, but then it's not necessarily detectable later in the season. We also see that high organic matter farms tend to have really high nutrients, and especially phosphorus. We sometimes also see that irrigation becomes challenging, that compost becomes sort of hydrophobic in the way that potting soil becomes hydrophobic when it dries out. And it is hard to like irrigate it adequately. And then occasionally we see situations, I see this especially when people have really heavy clay soil and then they have a thick layer of compost on top, or in urban soils where you have really compact soil to start with and then this sort of fluffy compost, that you get this separation layer where the water's not draining well, but you have all this decaying organic matter on top, and you can end up with a bunch of root rot pathogens that thrive on decomposing organic matter. And it's really hard to get rid of them once they're there. So that's organic matter. pH, useful for every farm, no matter what you're doing. It's really important to have the pH in the right range so that nutrients are available. This is something we see with heavy input soils as well, that the pH often is creeping up with all those compost additions. And I guess I often see soils that are in that like 7.5 to 8 range, where nutrient uptake is kind of becoming challenging. This is also not that hard to change. We can bring the pH up with lime. We can bring it down with sulfur. All right, so let's look at nutrients.
Can I ask a question about bringing the pH down with sulfur?
Mhm.
Because what I've never tried to do that or worked with a farmer who was trying to do that. And what I had heard is that that can be pretty challenging. So have
Yeah.
you, yeah,
I shouldn't say it's easy, but
okay. But there
yeah,
is a chemical way, like there is a
there is
way
a
of doing
chemical
it.
way to do it. So you
Yeah,
would add
okay.
sulfur to the soil and specifically not gypsum. I see a lot of organic vegetable farmers using gypsum for this. That is the wrong product. Like an ultra fine sulfur, like a tiger sulfur kind of product would be the way to do it. And it's best to not do it all at once, to do like a little bit every fall. And the idea is the microbes in the soil turn that sulfur into sulfuric acid and they bring the pH down over time. And we have some specific recommendations on amounts to use that I can dig up and share with Emily.
Can I
Yeah.
just add into that? Because we had to do that here.
Hmm.
And we did use gypsum and had some success, but it's because our magnesium was off the charts.
Okay.
And that was what was driving our high pH.
Hmm.
And so in that particular case, you're replacing magnesium on the clay colloid with calcium, which has a less liming effect than the magnesium. And then the magnesium and the sulfur are leaching out together as basically Epsom salt. So because we get more rainfall than evaporation, and because magnesium was what was driving the high pH, the gypsum was effective. Um,
Okay.
but it's not, you're right, it's a neutral product on its own. So it
Yeah.
doesn't exactly lower pH, but we needed to get our magnesium down, and and we needed to get our calcium up.
Okay.
And that's what they prescribed for
Nice.
that, and it worked, and it did bring the pH down. But it's a lot of gypsum.
Okay. All right, let's talk briefly about nutrients. So I always want like I try not to be too basic, but I think it's good to cover some of the basics too. So we have these 16 essential plant nutrients that plants are taking up every year. And so at some point we're taking things out of the soil and we have to replace them. Carbon, oxygen, hydrogen, plants get from the air and the water. We don't have to worry about those. The macronutrients, nitrogen, phosphorus, and potassium, plants are using in really large quantities. And those are therefore the nutrients that we're more concerned with replacing. The secondary and micronutrients generally are quite abundant in our soils that have been glaciated. Um, and so these tend not to be very limited in like our Midwest soils. Um, and plants are using them in much smaller quantities, but they can still matter. So just gonna start with the big ones. Nitrogen tends to like spur green growth in plants. Plants can only use it in a nitrate and ammonium form, so it has to be broken down from organic nitrogen. Um, Usually plants are yellow and stunted when there's not enough nitrogen. So traditional knowledge or traditional guidelines say we don't do soil tests for nitrogen most of the time. Um, and in part, nitrogen is really, really mobile. It like a soil test is not really considered like an adequate snapshot to make a recommendation for nitrogen in the same way that we do for phosphorus and potassium. Instead, we make that recommendation based on how much organic matter is in the soil, because that's considered a proxy for how much nitrogen that soil is holding. This is where I have like am maybe developing some mixed feelings. So I started testing for nitrate all the time, not as a way to say like, oh, you have 10 parts per million, therefore we're going to apply this much, but to help better understand how nitrogen is behaving in the system. So primarily I test nitrogen in the fall. And actually the 100 Farms project made me want to do this because we had assumed that we're perpetually lacking nitrogen in diversified veg systems, at least those that are relying on compost and are not using these synthetic nitrogen additions like urea or ammonium sulfate, things like that. But what we saw was like we did that project in the spring, and a lot of the soils had a lot of residual nitrogen from the year before. Um, I also now more tested in the fall, as a way to see like how much plant available nitrogen is still just like hanging out in the soil here. And as a way to sort of reflect on the year prior to say, like, did we have too much nitrogen in the system? Because if the nitrate is there in the fall, it's almost all likely to leach out of the system before the next spring. So that's a waste of money, especially right now. We're like facing fertilizer crisis, right? It's also not great for our groundwater. And in the spring, I really like to do a spring soil test for nitrate because, we may be irrigating, but we don't have rainfall in a tunnel. And so the nitrate that's in the soil is more likely to be available to the plants. And so we actually have some new high tunnel nutrient management guidelines in Minnesota where the rates are way higher than for fields because our plants in high tunnels they're growing a lot more, they're producing a lot more, they're using a lot more nutrients. But we find that a lot of high tunnels already have a lot of nitrogen in them. And so a rate like 400 pounds per acre sounds really, really high. But in a lot of cases, like if we're accounting for the nitrogen that's there, that's not actually the rate that you're applying. So in that 100 Farms project, in the spring, prior to fields really getting prepped for the most part, I see Sandy's on here. I think Sandy's like the one person in the study who had this like beautiful lush green high tunnel at the time that we visited. Most people had still not planted yet. So in fields, we had like 18 to 30% of a tomato crop's annual nitrogen need, still just like residual from the year before. In high tunnels, it was like 36 to almost 60%. Those numbers vary based on your yield estimates and your organic matter. But yeah, there was just more nitrogen in the system than we expected. And I think that partially comes from like we have all these organic inputs that are really slowly releasing nutrients over time. And it's so when you have like 6, 7% organic matter, that soil's just totally different than like a field that has 3% organic matter and has been in corn for years. So there's a lot of nitrogen in the system that is like slowly being released that makes it harder to do like really precise nutrient calculations. So those nitrate tests can just like help us better understand how it's behaving in the system.
I'm maybe you're going to get to this, but I'm wondering if you looked at cover crop nitrogen credits from cover crops. And I'm just going to call out that Andy had some questions about that because we've been working with them at Wonka's Harvest a little bit on their cover crops in their no-till system.
Okay,
And I've been
nice.
wondering about like as I read about it, there's so many different reports out there on how slowly or quickly the
Hmm.
nitrogen becomes available, and it's one of those like it depends
Yeah,
situations. So
it depends on.
I'm just curious what you've seen.
Yeah, I mean, we have our like sort of we're actually like I've been working with Julie Grossman's lab. We've got like 40 high tunnel farmers growing cover crops right now over the winter in their tunnels, and we're doing studies like actively to understand how that nitrogen is being released. Um, I think in general, like I wouldn't go with the SARE guidelines, unfortunately. I think our biomass tends to be way lower than what the SARE managing cover crops profitably estimates. So the best recommendation we have right now is to actually take a biomass measurement. So like do a quadrant, dry it down, weigh it, and then we have a YouTube video walking you through how to do it, but you're like multiplying by a factor of 4 if it's a legume, I think 3 if it's not.
And
Um,
we did that actually
Calculate your credit.
with Wonka's.
Yeah.
But yeah,
Our
that is a great
preliminary
video too.
studies for the
Can
high
recommend that to
tunnels,
people.
just like last year's data showed that at planting, the nitrogen was tied up. Like 2 weeks later, it was the same as a control plot. And then like a few weeks later, as the plant was actively growing, those cover crops were like actively releasing nitrogen into the system. So I think we should for sure be considering cover crops in our nitrate credits. The other thing we should be doing is testing our irrigation water in high tunnels. We often have scary amounts of nitrate in Staples, Minnesota. You can get a 90-pound per acre nitrogen credit just from your drinking water, or your irrigation water.
I'm also curious, hi Andy, about like the different types of cover crops. Like
Mhm.
obviously your legumes are probably gonna add more nitrogen to your soil than say like a rye. What kind of wisdom do you
Yeah.
have to say about that?
Yeah, so what's tricky about, so you actually can take a nitrogen credit even from a non-legume. And the idea is, and this is where there's some nuance, like if there's still nitrogen in the soil, um, the your rye is like holding that nitrogen in place. So instead of leaching out, it's using that nitrogen to grow, it's holding on to it in its tissues. And then as it decomposes, as your plants are growing, it's releasing that nitrogen back into the system. And so it's not adding nitrogen, but it's like preventing the subtraction of nitrogen, I guess.
Okay,
And
that's
that,
really
of
cool.
course, it depends how much nitrogen is there, right? So some people will fertilize their cover crops. I think that's also where, like, if you did a fall nitrate test before you planted your cover crop or around the same time, that could sort of inform how much extra nitrogen is there. Is the rye going to efficiently use it? And it's really, that's one of those things that's like, it really is more of an art than a science. Like the dynamics of how much nitrogen that crop's going to take up, kind of complicated. And then, like, let's say it's a super dry summer and there's not a lot of biological activity happening, like that release rate's going to be slower, although we're all irrigating. So there's a lot to learn still, but cover crops are certainly like a really important part of the equation. A couple other things about nitrate. In high tunnels, we have a salt problem. We see high soluble salts. And in our 100 Farms project, we tried to correlate high tunnel salts with soil pH, didn't see anything. With water pH, water alkalinity, you didn't see anything. A couple different, like calcium, magnesium, nitrate was the only thing that was significantly correlated with high tunnel salts. And so, like, the assumption there is that a lot of the soluble salts in our high tunnels are actually nitrates. Um, and that is a result of over applying. And it also means that if we're practicing the traditional approach to soluble salts, which is leaching them out, we're just leaching nitrate out of our high tunnels. Um, so I could talk a lot about that, but that's all I'm going to say. And also that if you are in the driftless regions of Minnesota or Wisconsin, that's an especially high risk. Like the risk of nitrate getting into groundwater is really high in those areas with karst geology. So we have to be especially careful. Okay, I'm gonna keep speeding on because we don't have a lot of time to chat. So phosphorus, um, helps plants do a lot of things. Sometimes we see purple leaves in the spring when it's cold because plants are not effectively accessing phosphorus yet. Usually that just means the soil needs to warm up. Um, Generally, we see really high phosphorus on vegetable farms. Here's a graph again. Low, medium, high are like yellow, brown, green. So the average Minnesota field crop farm has 39 parts per million phosphorus, according to the Bray system. That's high. Uh, the average vegetable field in our 100 farm study had over twice as much. And it was like in the really high category. High tunnels were like really, really high, 178 parts per million. And this is kind of just a natural outcome of pretty input heavy systems as we end up with a lot of phosphorus. So 87% of high tunnels, 84% of fields had very high phosphorus where we wouldn't recommend adding any additional phosphorus. And this matters for a few reasons, mostly from a water quality perspective. Um, Phosphorus is the limiting nutrient in freshwater systems. When that phosphorus is more likely to leave our farms when concentrations are high. So we see pretty clear correlations between soil phosphorus and the amount of phosphorus leaving our farms as runoff. And so your risk is really related to the surface water around you. Like Do you have a wetland on your farm? Do you have a stream running through your farm? What is the slope? What is the distance? And for urban farms, like, are you near a storm drain where any runoff is going to go straight into the system? Um, a less like something that matters more for like your direct farm productivity is I can finally start to talk about this. We Devanshi Kokani's lab actually like sequenced the microbial genomes of the farms in the 100 Farms project. Um, and in general, when farms were really high in phosphorus, we saw less arbuscular mycorrhizal fungi. Um, and that's something we kind of expected, but it's also what we saw in reality. Sometimes your expectations and reality don't align. Um, and so essentially the idea, the assumption there is like, I'm going to anthropomorphize these plant roots, but like for the plant roots to form an association with fungi in the soil, it takes some effort to have that relationship. And if there's so much phosphorus there that they don't need help from the microbes, they're not going to put the effort in. That's also what we see with rhizobia. Like if there's a lot of excess nitrogen in the system, those legumes are not going to form those associations and they're not going to fix extra atmospheric nitrogen because that's a lot harder than just taking the nitrate that's there. So we do actually see shifts in the microbial community when we have these really nutrient enriched systems.
Can I ask a couple of questions about the phosphorus stuff?
Yeah.
Um, on your previous slide, when you were talking about parts per million, that was actual phosphorus, not phosphate. Is that right?
That was phosphate. No,
Phosphate.
that's parts per million Bray. What is Bray reported in? I should know.
I don't know. I thought Bray was just the type of acid
It's
that they
just,
use.
it is, yeah. But the parts per million reporting, I think that would get translated into a pounds per acre needed of phosphate in the recommendation. But let's see if we can see on the soil test. That's a great question that I should know the answer to. Just, yeah, phosphorus parts per million is how it is reported. And then the recommendation gets translated into P2O5 pounds per acre. So it's the amount of phosphorus that's extracted from the Bray extraction. It's not total P.
Not total P, right? But it's just measuring like so phosphate is twice as heavy per unit of phosphorus as just the phosphor, I don't know how to say this. Sorry.
Yeah.
Um, so if you're recording parts per million or pounds per acre of phosphate and you want to convert that to just straight phosphorus, you have to like multiply it by 0.44. So it changes the number pretty
Yep.
dramatically.
So it's phosphorus, just
Just
P,
phosphorus is what they're
elemental.
measuring there.
They're not measuring P2O5.
And then my question is, so the like whatever soil calculation sheet that I use calls for way, way higher phosphorus than most other recommendations.
Do you
Um,
know why or who came up with that sheet?
it's from the Intelligent Gardener, so it's not like a fertilizer salesman. It's just somebody going through the Albrecht
Okay.
method and trying to make it like easier to sort out, as far as I understand.
So I guess
And
I would say that these recommendations, so these are the University of Minnesota recommendations. Um, and they are based on like research trials where we're looking at if you add additional phosphorus beyond this point, do we expect a yield response? And
mhm,
so that is the point where we no longer expect a yield response.
mhm,
And so essentially the idea is like you're spending extra money to add phosphorus to the system, and you kind of enter this zone where like the risk of applying more is runoff and the benefit is no longer being seen.
right.
So
Um,
that's just like the framework of where these numbers come from. And they're
sure.
different for every vegetable. But that's like the point where there are no longer any vegetables that we expect to see a yield response from.
Gotcha. Yeah, I always find it kind of troubling because I mean, it's hard to move that phosphorus number.
Yeah.
Um,
It's really hard to bring it
and
down.
well, it's hard to bring it down, and it's also hard to bring it up. I mean, not if you use like if you're doing deep compost mulch on small acreage or something, that's not that hard. But if you're not using DAP or MAP or anything like that, just with organic inputs, it's a challenge to move it up very fast, but it does keep moving up over time with compost additions. Um, and it also, like your zinc and sulfur sweet spot are all tied to phosphorus.
Yeah.
And so I feel like if for whatever reason the recommendations I'm using are having me moonshoot phosphorus, then that's throwing all that stuff out of whack.
Yeah, at some point, I think it has to be pretty high, but at some point, too much phosphorus can inhibit zinc uptake as well.
Right.
Yeah.
Have you considered doing strips in your field, Henson, where you vary phosphorus inputs? You know that can be really hard to do with organic inputs where you're bringing a lot in together, and also if you're using rock phosphate, the rate at which that becomes available is very, very slow.
Right.
But
I mean, I feel like some of our tests are just now starting to show from rock phosphate I added years ago.
Mm, yeah.
So I don't know how I would do a test without, I guess I could break into new ground or something, but I'm historically poor at test plots.
Yeah, I'll have to look up the intelligent gardener and see more about where their phosphorus tracks are coming from. All right, I want to talk about potassium because it's linked to some other tests, and then we'll quick talk about micronutrients and Albrecht and stuff. So potassium, super important for fruiting. Um, Yellowing edges of the leaves is kind of the main potassium deficiency symptom. And I feel like potassium's all over the place. Unlike phosphorus, which like I tend to see being consistently really high. I see plenty of farms where potassium's super high, a lot of farms where potassium's really low. Um, and we often see deficiencies in high tunnels and urban soils and high organic matter soils, even when soil test levels are showing high potassium. So this is where some adjustments come in. Um, and yeah, it's when the water pH is too high, it can also be hard for plants to take up potassium, especially in high tunnels. So I'm just gonna talk really quick about some additional tests before we look at these more specialized testing. So what else should we be testing for? Contaminants, we should be testing for lead at least once in urban areas. This like secondary nutrients, I think, are the most complicated and the most contentious. So I think it's worth vegetable growers testing for calcium, magnesium, and sulfur on a regular basis. Um, we see a lot of sulfur deficiency, or not a lot, but enough that it's worth testing for on a really regular basis. Um, I think calcium and magnesium are the trickiest because there's just like people have so many opinions about calcium and magnesium, and there are so many different approaches, including the Albrecht method. Um, and yeah, people have so many opinions, and people feel really strongly. And so it always feels like you're going to say the wrong thing. But I think and I'm not saying this is the best take, but like the sort of current place where I'm at with calcium and magnesium ratios. And Brew, like if you have opinions, I'd love to hear too. But the Albrecht method came out of some really specific tests that happened in Missouri in the 1930s. And we have consistently seen reports from Wisconsin and Minnesota where we're looking at soils with different ratios of calcium and magnesium, and it doesn't seem to matter. Like, it doesn't seem like there's a perfect ratio. We can grow healthy crops in a variety of ratios of calcium and magnesium. Something we do see, again, in these really heavy input systems is that calcium can get so high Um, and actually, Judson Reed in New York has shown this in his research in high tunnels that when calcium levels get high enough, they start to hinder potassium uptake. And I just see like so many potassium salespeople, or not potassium, calcium at trade shows on the floor, like telling you that calcium is your problem. And often, like if you're seeing blossom end rot, it's much more likely to be a consistent water thing. Marissa, my coworker, talks about calcium as the bag lady on the plane. Like she's definitely there, but it takes her a really long time to get through the aisle because she's got too many bags and she's trying to get through a small space. And like that's what's going on with calcium. And adding more to the system does not fix the problem. It's like getting enough consistent water into the system to make it easy for that potassium ion to push through the plant and into the fruit. And so I know, like, I feel like I'm gonna alienate people when I say that because I know that like people have really invested in calcium magnesium ratios, but I guess I'm not convinced that it's worth it. But I'm totally open to people's thoughts and to hearing what you've learned too.
I will just chime in really quick. Research out of Wisconsin has shown the same thing, Natalie, that there's not like an ideal ratio of calcium and magnesium.
And maybe I'm just gonna do these last couple slides about these other like modified testing methods, and then we can discuss some more. Um, okay. I am seeing a lot more discussion about saturated media extract is like the thing we should be doing instead of soil tests. Saturated media extract was developed for greenhouse potting soils where like there's no soil involved. It's just like peat and perlite. There's no ability for that like mixture to hold on to nutrients in the way that soil does. Um, so a regular soil test will show you like what's likely to become available over a whole season. In a saturated media extract, you're just like adding water, making a slurry, and seeing what comes out in the water. And so it's like what is immediately available in water. And that is really useful when you're making moment to moment decisions in a greenhouse where like you don't have soil that's releasing nutrients. You're providing all of the nutrients along the way. Um, it's really effective for soluble salts. We use it in high tunnels to see what the salt levels are. That's great. That's super appropriate. It can be effective for testing nitrate. So can a regular soil test. It's not reliable for micronutrients. And I see people looking at phosphorus with it and saying, look, my soil test says it's really high, but the SME is really low. Um, and I don't know that that is how we should be using this test. I also I think it's sometimes tied to people selling us kind of expensive custom nutrient mixes. I am still learning a lot about this. There's a really helpful video on YouTube. It's a webinar that Zach Grant in Illinois did about saturated media extract that's way more in depth that I would recommend watching if it's something you're interested in. What I am more excited about is the work that's coming out of Cornell on bulk density. So the assumption when we do a soil test is that we're taking a 6-inch slice of soil and that a 6-inch acre section of soil weighs a certain amount. It's 2 million pounds. And so that affects the way that we're assuming the concentration and the density of that soil. What we see when soil organic matter gets really high is that those bulk density assumptions are not very accurate. So these are the 100 farm soils, fields on the left and tunnels on the right. Even some regular soils have kind of low bulk density, but as we start to get above 5% organic matter, we see really low bulk density. And so our basic assumption about how much soil is present in that slice of soil is not accurate. And so the Cornell team has developed this bulk density adjustment, and I'll send this fact sheet out as well, where you can take a bulk density sample and then use that adjustment on your soil test value. And this primarily affects potassium. So they were seeing super high potassium everywhere they went, but then when they started to do this adjustment, they saw like, oh, actually, a lot of these soils could really benefit from potassium. And that matched what they were seeing. They were seeing potassium deficiency symptoms. And then I'm still a big fan of foliar tests for adjusting within the season. Um, I'm not as much of a fan of sap tests. I think I've now worked with enough farmers who've done them that they're really, really expensive. You're getting these sort of mystery custom blends back. It doesn't seem to really increase their yields enough to make it worth it. I think if you're really excited, there's nothing wrong with doing it, but it's a big investment. A foliar test is pretty cheap and easy, and it allows you to make those mid-season adjustments to see like what are my plants actually taking up. Um, Usually you would do it on a crop like tomatoes where you have this long bloom time and you would do it with the first flowers so that you're making sure that as your plants start to need a lot more potassium, you're like getting that right. Okay. I'm gonna stop sharing. I will say we have our like weekly newsletter that goes out every week now with crop updates from the field. And as I'm like investigating more of these things, that's a place where I'm gonna be, I guess, writing a lot about what we're learning as we look into tests like the saturated media extract.
Just a plug. I love your newsletter, Natalie. I check it out. So this was great. Thank you so much. Does anyone have any questions for Natalie?
I would love to hear like it sounds like you're using a lot of like calcium, magnesium balancing and like how that's going and how you're using it.
Yeah, I don't know. That's been my kind of biggest focus because magnesium was our thing that was the farthest off. Well, magnesium and iron are like way off the charts, both in um, I do a Malic 3 test mostly, but I have also done like a total digest test to see like what's all there. And in both of those cases, they're just kind of like off the charts. So
Like they're
I,
really high.
yeah, really high.
Okay.
Phosphorus was really low when we started, and we brought calcium, and calcium was pretty low. Um, so we've done a lot of gypsum. Sulfur was also low. And just to try to, at least in that top 6 to 8 inches, get the magnesium and calcium ratio more balanced, in the hope that that makes it easier for that bag lady to make it up the plant. Um, and I don't, like I said, I'm no good at test plots. We throw everything we got at it all the time, and we do everything at once. So it's
Yep.
really hard for me to say. The soil has certainly improved. Yields have improved, pest and disease issues and evenness of the stand have all improved. Um, but also just the workability of the soil. I mean, it used to be if we got a inch of rain, it was like a week and a half before we could go out there, and now we can get out into the field next day sometimes.
Because it's
So
draining so much better.
yeah, yep. And the texture is just totally different. It doesn't cake up and smear onto everything like it did before. It just kind of like squishes and comes back more. I don't know.
Yeah.
And we've brought organic matter percent up with that as well, maybe like 1% in 10 years, so nothing that I'm super proud of. But that I think that helps that. Um, and then we just have, I mean, I really, really try not to have it go very long without plants in there. So we do like living aisles and stuff like that, which also makes it a lot easier to get out in the field. Um, and just tons and tons of cover cropping. But I don't know. I I guess I felt like from what the research I was doing that the calcium and magnesium ratio was probably our biggest issue, and that's what my focus has been on. But it's a hard needle to move, especially because the magnesium's high. You can add calcium, but taking the salt back out of the soup is harder.
Right. And plants are using so little of it that
Right.
that's like you're not going to draw it down in the same way that you're going to draw down potassium or something.
Right.
And I think that's also why it's hard to study these. It's like, you're doing everything. Like you're doing so much to improve the soil that it is hard to say that like, oh, this one thing is what moved the needle when like
Right.
it very well might be. Um, and I think like if something's working for you, then keep doing it. Right? Like the goal is not to say like, no, stop balancing calcium and magnesium. I think my only take is like we see enough studies where those ratios are different and like crop productivity is good that it makes me anxious to like recommend that people spend a lot of money and time
Right.
like getting to some perfect balance. But like if it's working and it's improving your soil, then like that's great.
Yeah, I don't know. It seems to be something is. And then this kind of gets to the next question I have, which is, we've got these imbalances, and they always say that your excesses of nutrients can be causing you as much harm as your deficiencies of nutrients. Um, and so I guess I'm always kind of wondering so for example, if our magnesium is way too high, can we just keep pushing calcium higher to like, because they talk about ideal amounts, but then they also talk about ideal ratios. So which is more important? Like if the magnesium's already there, should we push the calcium to get that ratio right, or do we just take it up to the full recommendation and then I don't even know. I don't know how you get the magnesium out without pushing something else out of balance because that's
Right.
the only
At
way to
some
move
point,
it.
it's like more calcium may not actually be helping. That may end up causing its own problems, right?
Mhm.
Um, when you say magnesium is like super high, how high is it?
Yeah, great question. I got that pulled up here, but my computer went to sleep. Um, so for example, we've got one field where the value found is 417 pounds per acre. So that'd be like 200 parts per million, 210. Um, and for a desired value, they've got in here 247. And this is from Logan Labs, and it kind of loosely corresponds with the other stuff I'm using. So, but then
That
also
seems like just a really normal amount. Like,
well, I think for here it is. I don't think it's
yeah.
unusual, in our area, but, then on the base saturation part, we're like into the 20s, even high 20s. Magnesium versus calcium is kind of low 60s. And, basically both things are kind of like just outside the ideal window. But I also know that that's only the top 6 inches. And I know that if I go 6 inches below that, it goes way sideways. So,
Yeah.
because
And
we that's where we've already been working on it for 10 years.
what is the total amount of calcium?
Um,
I don't mean to like grill you in
like
front of
no,
everyone.
no, I'm
Just
all about this. You're not gonna hurt my feelings. Like 2,300 to 18 to 2,300 pounds per acre.
So that's also like really high. That's
Oh
not a
yeah,
low amount of calcium.
no. But so my understanding is that in order to move that magnesium out, we've got to undersupply calcium and oversupply salt, adjust those things. We've just topped up calcium according to the recommendations that I'm using. We're like pretty much at what they're looking for.
Yeah. Yeah,
Or I
I
shouldn't
think
say
that's
that. This
where
was
like
right before I put 1,000 pounds of gypsum out. Sorry, go ahead.
yeah, I think that's where like those, we have dozens of studies showing different ratios where like that's going to affect the base saturation, right? Like a different ratio
Mhm.
where it's fine at all of those different ratios. And I mean, like if you're at like 300 to 1,500, 1,800, that I
Yeah,
guess that seems pretty standard to me.
four, yeah, 400 to 2,000 would be kind of an average. 400
Okay.
pounds per acre of magnesium and 2,000-ish pounds per acre of calcium.
So that's like a 1 to 5 ratio, more or less. Yeah, that's a 1 to 5 ratio.
Yep.
What is the ideal Albrecht method? It's like 1 to 8?
Yeah, 1 to 7, 1 to 8, something like that.
Okay. Maybe that's a task for me and Emily. You're gonna rope me into this, Emily, to dig up a few of those studies to show like what is that range, like in those studies that had different ratios and
Right.
like crop yields remain the same. Like what is that actual range? Um, if it's 1 to 6 to 1 to 8, that's really different than a range of like 1 to 2 to 1 to 15, and it was all still okay within that
Right.
range. Um, so I'd be happy to try to dig that up and like just see what that range is. Um,
Yeah, I'd be really curious because, like I say, I mean, I've already uh, put a bunch of time into this particular thing, but I'm totally game to walk away from that. I don't like I don't need it for the sake of having a project.
yeah,
Um, I do think that, a lot of recommendations that come out are not vegetable centric. And so,
yeah,
and a lot of studies that get done, and it could be that the juice isn't worth the squeeze if you're growing corn and beans or whatever. But,
yeah,
if you look at the dollar value on an acre of vegetables compared to the dollar value on an acre of corn and beans, it's so dramatically different that all of a sudden what makes sense, if all I'm getting is a 10% yield bump and it costs me $10,000 once or $1,000 a year for 10 years, that still pencils, you
yeah.
know. Um, the
And
other
so the
costs, the
Albrecht
other costs are
method,
way high. Labor is like a
right?
way higher than
Yeah, you're already
fertilizer.
out there like adding stuff to the soil, adding a
Right.
little bit, something extra is, yeah. Um, I have this old article that we wrote about the Albrecht method that I'm gonna revise and review. It did come from alfalfa, like
Mhm.
alfalfa in Missouri. Um, so I don't know. It looks like the Albrecht method in Iowa cost an extra $9.72 per acre. So yeah,
Yeah.
if you're growing 10,000 pounds, 10,000 acres of corn and soybeans, that's a lot of money. If you're growing 5 acres
Right.
of vegetables, $9.27 an acre is a pretty low investment.
Right. Yeah. And so that's kind of the question is I feel like, well, if that's the case, then I might as well just, you know, go for it and just really try to top all that up. Um, the hardest part has been like the micronutrients. It's hard. I do add them, but it's hard to like get them to show up on the soil test. It's such a small amount anyway. And then B, like, I don't know if you've ever tried to buy molybdenum, but it is not easy. And nickel's even harder.
Yeah.
Like, I think actually just putting nickels out there would work better. I can't find, I mean, there's like nothing.
Yeah.
Very few products, and if they are, they're like 0.003% something, so you have to commit to using that product on a for all the other things that are in it. Um,
Yeah. I also like I I question a little bit like what it's all based on. Like when people are saying like the correct amount of nickel in the soil, like is there like who made that
Yeah.
choice about the correct amount of nickel and like how many soils was that tested in? And again, like if you feel like it's benefiting your soil and it's worth it, then like go for it. But I think sometimes like we just have a lack of research, and then it's like the only information we have is coming from people who are selling things. And that's a
Right.
problem for all of us, right? It's like I don't have a good answer for you. You don't know who to trust. Like, um, so unfortunately, I think that is the situation we end up in with a lot of micronutrients. And
Yeah.
that's a
No,
frustrating
for sure.
situation to be in, but we're
Yeah,
not going
no, it
to have
really
any
is.
answer.
And I guess I think that biology can overcome a lot of imbalances in the soil. Um, so I think, research into how to best manage soil biology is also probably warranted because I think, you
And
stand to
that's where
gain
like
the most at the
those
least cost that way.
right, those other practices you're doing, we know a lot more about, and we know the ways that they benefit soil biology.
Mhm.
Like reduced tillage really matters for aggregate stability and soil structure
Yeah.
and for mycorrhizal abundance and having cover crops and living roots in the soil, like all those really basic things that I like feels redundant to keep saying them. But I think those like long-term soil health practices generally work better in the long term than quick fixes. And that's not to say that sometimes we have an imbalance that we need a quick fix for, but
Right.
yeah. So sorry to not have better micronutrient responses. There probably are
No,
people that like could be in this next year that know a lot more about micronutrients than I do. Like I said, I'm not a soil scientist. I'm just a agronomist who's grown vegetables for a long time who is trying to figure out the sort of big picture trends. And I think, yeah, in the big picture, like we have big imbalances to address. Like in addition to those more minute changes, like
Mhm.
the yeah, the ways that we're applying compost and like the orders of magnitude of like extra phosphorus in the soil. I think those are things we can talk about more for sure. And then I think we like where we all need to learn more. We being like researchers need to study more and universities need to learn more about is like once you have that sort of, you're like in the right order of magnitude for the big things, like where do those like small changes and fixes really matter? And that is like, yeah, I keep thinking about like the SAP analysis, um, which it's like companies like AEA where like you're doing this weekly SAP analysis and sending leaves to the Netherlands and they're sending you these custom nutrient blends with all these micronutrients. Um, and we need more studies like this. They're like the Dina Jogla, who works with Johnny's Seeds now, and David Van Eck out at the Good Acre did a study where they were like comparing half of a high tunnel where they were doing that and half where they weren't. And it was like all this work and money, and they didn't see a difference at all.
Mhm.
But that's one farm, right? I think we need more of that kind of thing just to really understand those questions of like, is it worth it to make these small micronutrient changes or not?
Well, and I think, if the high tunnel was already in really good shape and it's well
Exactly. It
managed,
was.
then there would be less room for improvement there. And that was always kind of my hope with doing this was that I wanted to like take soil tests in the fall, spend all winter figuring out what I'm going to do about it, and then just put it out there once in the spring and then be done for the year because I don't want to side dress and foliar apply and take tests during the season. It's all
Yep.
the time I could be pulling weeds.
Yep.
Well, thank you.
Right. Yeah. Good discussion. Thanks,
Yeah, this
everybody.
was great. Thank you.